Hello everyone! Today we are going to analyze pictographs. Have you ever come across into some advertisements or reports in which the statistics are presented in figures? Like example, 4 out of 5 dentists chose Colgate. Or from here, 92% of people whose ages range from 18 to 23 find it easier to read print over digital content. So, in which 92 here is presented by a series of man figures in which one or a part of it is not shaded. Or have you ever come across into figures on your app gallery wherein apps are rated according to 1, 2, 3, 4, and 5 stars? Or even some restaurants are trying their best to have the utmost service, to have the most delicious food, the excellent service just to get the 5 Michelin stars? That is our objectives for today. At the end of this video, you will be able to 1. Identify parts of a pictograph. 2. Compare a correct pictograph to misleading pictographs. And 3. Solve problems involving pictographs. Hello everyone! My name is Jofet Villanueva Lasso Vargas, or you may just call me Teacher Faith. Let us review. Data is presented in two ways. 1. By tables, and 2. By graphs. As discussed on the previous video, tables directly present data in numbers according to the variables or categories presented, while graphs present data in a visual form such as lines, shapes, and pictures with the variables and categories presented. Pictographs belong in such way in presenting data. In order for such graph to be formed, a collection of data must take place. In the Philippines, there is a trending type of survey called Kalye survey. Kalye is a Filipino term which means street, in which the one who is taking a survey are asking people he met on the spot of which presidential candidate they will prefer, and each answer will convert will be converted into a tally. Now, this type of survey may not be as reliable compared to an actual election this coming May 2022, but at least it gives a light to what presidential candidate is being preferred by those people in a certain area. Just like in your classroom, sometimes we would like to ask, "Oh, classmate, what is your favorite snack?" And then one classmate will say, "A burger," and then you're going to create one mark. One classmate is going to answer ice cream, and then you're going to create one mark. And when such mark has come up with 5, 1, 2, 3, 4, we will try to create a slant. And this is what we call tallying. But how about if such group of marks, we can convert it into a symbol? Smile. Let's take for example that one. Each 5 marks, we can convert it into a picture. We have here smiley, another smiley, smiley, and the rest smileys. So that will be our key here. Each smiley will represent 5 students who voted for that food in which they considered it their favorite food item. This is what we call pictograph. In mathematics, a pictograph is also known as a pictogram. Is the pictorial representation of data using images, icons, or symbols. We can represent the frequency of data while using symbols or images that are relevant using a pictograph. Pictographs are one of the simplest way to represent data. So what are the parts of a pictograph? First, we have here the title. The title gives an overall description of what your pictograph is all about. Second, we have here the categories. The categories will present to what specific type of item are being under the survey. Next, we have here the data. The data gives here the visual presentation of how many preferred to the type of category here presented on the left. And the last and the most important, we have the key. The key gives the numerical presentation of how many each icon, symbol, or picture represents. There are two types of pictograph. We have the horizontal pictograph, like this, from left going to the right, whereas here we have the vertical pictograph from down going up. Be careful because there are many types of misleading pictographs. Let us take this for example. On the first look, we can see that there are more bananas than apples and cherries. But if we are going to count, there are 4 bananas, 4 apples, and also 4 cherries. So this is misleading. But the correct way to make a pictograph is have all those pictures into proper scaling regardless of how it is presented in the real size. An improper scaling the 2D bar graph. Here we have this picture, whereas on the B it is enlarged. But if we are going to create a comparison from the regular, it has 9 times as large as A. So it is quite misleading as not only it increased in height but also in the width as well. For the 3D pictograph, not only the length and width is increased but also the height as well. So in the improper scaled 3D pictogram, the space is cubed. So let us not be misled into these types of pictograph or try to make one. So, when a graph is already presented, how will we use the graph? First, read the title and categories. We have to be careful that we are using the proper graph in answering the questions. 2. Take note of the key and use it by multiplying to each symbol or picture as presented on the data. You can write the equivalent number to remember easily the data. And 3. Use the data in answering the questions. Just like the rest of the tables and graph, we have to note, do not use what is not asked. So, let's practice. We have here an example table 1, mode of transport of students going to school. So we have different mode of transports. We have bus, car, walking, bicycle. Our key here, each smiley represents 4 children. Let's proceed to our question number 1. How many students are taking the bus? So we have this bus. Each smiley represents 4 children. So 4, 8, 12, 16, 20, 24, 28. Or simply, there are 7 fours. That means 4 multiplied to 7, we have 28. Number 2. How many students are using bicycles? So we have 4 times 3 equals 12. Okay? Are you with me? Number 3. How many students walk than those who ride cars? Now, in order for us to remember well when it comes to comparison, it is most likely to recommend that we put some numbers altogether around these 4 as part of your solution. But in this case, I would just like to focus on walking and cars. So we have walking 24 as this 1, 2, 3, 4, 5. 4 times 6 is 24. And cars, we have 4 times 1, 2, 3. 4 times 4 will give us 16. How many students walk than those who ride cars? What will we do? 24 minus 16. So our answer is 8. Okay, very good if you have the same answer. Number 4. How many percent higher are there who ride cars than bicycles? So let's make some numerical marks again. Those who ride cars have 16. And those who are using bicycles, you already have here 12. We are going to compare them. Percent higher, that means we will use the percentage. Okay, 16 minus 12 will give us 4. So there are 4 more cars than for more students using cars than using bicycle. And compare it to the bicycles than bicycles. So we have the 12. So we have 33, 0.333, or we can convert it into percent, moving 2 decimal places to the right, 33.3%. Okay, very good. Our next pictograph is all about pumpkin harvest. The pictograph shows the number of pumpkins harvested by 5 farmers in the fall season. Use the graph to answer the questions. Okay, so number 1, who harvested the most? Okay. Since a number is not being asked here, we can just look up at the scaling, okay, and to those who have the farthest, okay, scale of pumpkins. So we have Farmer Edwin. Number 2, how many pumpkins did Jacob harvested? So where's Jacob here? Okay, we see already Jacob. 50. So each one is 50. 50 plus 50 is 100 plus half of 50. We have 125. Number 3. Who harvested 250 pumpkins? So in this case, we do not know how many each had harvested. We have to consider converting each one into numbers until we came up with who. The farmer had harvested 250 pumpkins. Let's start off with Danny. Danny has 50, 100, 150, 200. So no, it's not Danny. Is it Jacob? Jacob already has here 125. So no, it's not Jacob. Let's go to Ray. 50, 100, 150, 200, 250. Oh, 250. That means the answer is Farmer Ray. Number 4. Name the farmers who harvested the same number of pumpkins. So, looking upon this pictograph, we have to know which of the farmers have aligned pumpkins. So, who are they? Who? Okay, very good. So we have Johnny and Alex. So you can see here 1, 2, 3, 4. So aligned here is also Alex. We have 4. Okay. 5. Honey, sorry. Danny harvested more pumpkins than Ray. Is that true? So we have to consider here Danny. Danny here has 4 pictures of pumpkins. Okay. While Ray has 1, 2, 3, 4, 5. So which has more, Danny or Ray? Oh no, it's Ray. So that means no, it's not true. Okay, this time you try. Let us start. A city has 3 public library branches. A librarian kept track of the numbers of books checked out from each branch in a week. He used the data to create the pictograph below. So, our branches are North, South, and West. And these are the books checked out from March 4 to March 10, in which each book here presented is 150 books. Question: how many more books were checked out from the North Branch from the South Branch during the week of March 4? So, when we say week, that involves 7 days starting March 4. So, March 4, 5, 6, 7, 8, 9, and 10. So, week of March 4 is the same from March 4 to March 10. So since we are already involving big numbers here, it is recommended that we should calculate and put into notes here on the right of how many books are there. So let us count. North, let's start with North. 1, 2, 3, 4, 5, 6. 6.5. So 150 times 6.5, we have 975. You may check it with your calculator. For the South, we have 1, 2, 3, 4, 4.5. So 150 times 4.5, we have 675. The question is, how many more books were checked out? That means we get the difference, 975 minus 675. Our answer is 300 books. Question number 2. How many more books were checked out from all 3 branches combined? That means we have to know how many books are there here in West Branch. 1, 2, 3, count with me. 4, 5, 6, 7, 8, and 9. So 150 times 9, we have 1,350. Add them all because we are asking for all 3 branches combined. 975 plus 675 plus 1,350. Our answer is 3,000 books. Did you also get the same answer? Very good. Now we proceed for our last pictograph. Okay, for our last pictograph. Mayfair parking garage, a daily average of parked cars by time period. So we have this cars and we have this time period. 8 a.m. to 12 noon, 12:01 to 4:30 p.m. and we have 4:30 to 1 to 8 p.m. Our question is, how many cars are parked in the garage from 12:01 to 4:30 p.m.? A. 275, B. 350, C. 375, or D. 650. Okay, so we have to take note that our time being rendered here is 12:01 to 4:30 p.m. So this is the one. Okay, so let us count. You can manually count by 50 or you can use your calculator, or if you have a sharp mind, you can multiply it directly. So to have a detailed discussion, let us count by 50s. 50, 100, 150, 200, 250, 300, 350, plus half of 50, 25. So we have 375. Okay, so we can also use 7.5 times 50 is 375. Our correct answer is letter C. For our last question, how many more cars are parked from 8 a.m. to noon than are parked after 4 p.m.? Okay, A 75, B 100, C 175, or D 200. So we're going to take into consideration what time period is being asked here. So 8 a.m. to 12 noon is this one. Okay, so how many are there? 275. 1, 2, 3, 4, 5 times 50 is 250 plus half 25, so 275. After 4:30 p.m. So after 4:30 p.m. is this one here below. So 50, 100, 150, and 200. So we have 200. How many more cars are parked? So we subtract 275 minus 200. Our answer is 75. Did you get the same answer? Very good. Marvelous. Give a hand or a clap to yourselves. Congratulations. Now you have completed this lesson. You can be able to understand better our next lesson. And our next lesson is about bar graphs. Before I end this video, I would like to share with you a simple Bible verse. Every good and perfect gift is from above. James 1 verse 17. As every picture, icon, and symbol gives data to the pictographs, and so are we in God's kingdom. Have a good day, everyone.